In this video and the next two, I'll be looking at some advanced topics in Surds as we gradually bring this playlist to a close. Nested Surds is what we are considering in this video. And of course, we already know what a surd is by now. And when we talk about a nested surd, it is simply a square root that contains another square root inside it. So that's it's like you have a surd inside a surd, basically. That's what's called a nested surd. An example would be what you have as this square root of 3 plus 2 root 3. So the goal is often to rewrite it as the sum or difference of two square roots, usually in the form square root of a plus square root of b. So you can actually write nested sorts as the sum or difference of two square roots. So the process of doing that is called denesting the surd. So when you have a nested surd, you denest the surd to get the sum or difference of two square roots. So the key idea is that suppose you have square root of 3 plus 2 root 2. And that, so you want to express it as root x plus root y. So if that is the case, you can then square both sides. So if you square root of 3 plus 2 root 2, the square cancels the root, right? And you have 3 plus 2 root 2 left. And when you square this one, you have root x plus root y all squared. And root x plus root y all squared, following the rules we've always known, root x plus root y all squared will simply be something like this. You have root x, you have root y plus root y all squared. So you have, that'll be root x all squared plus 2 root x root y plus root y all squared, following if an identity we are very used to. That's this identity, that's a plus b squared equals a squared plus 2ab plus b squared. Following that same kind of argument, then you have square cancels root, so you have x plus, you have two roots x plus root y is root xy plus square cancels root again, so you have y here. So this is the kind of expression you have, and then x plus y now is the part without the radical, and then you have 2 root xy, which is the part with the radical. So that's the kind of thing you have when you expand like that. Okay. So now having taken care of that, and we got x plus y plus 2 root xy, then we then compare that with we compare the left with the right. So the left hand side is 3 plus 2 root 2, the right hand side is x plus y plus 2 root xy. So if we compare, what do we get? We have we have 3 plus 2 root 2 root 2, and the rational part is we have x plus y plus 2 root xy. So if you compare the part without the radical for x plus y, you have it here. So x plus y, if you compare it with this, that's x plus y equals 3. On the other hand, 2 root xy, 2 root xy compared to 2 roots 2. That means you're going to have 2 root xy equals 2 root 2. So you can divide both sides by 2. So you have root xy equals root 2. And you can take the square of both sides. So when you take the square of both sides, you get xy equals 2. So now you have two equations, x plus y equals 3 and xy equals 2. So the equation is very easily solved. You don't even have to go through the formal process of solving a simultaneous equation, because usually what this is telling you is you need two numbers. When you add, you get 3. When you multiply, you get 2. Usually, the two numbers will be positive because there's no negativity here, except when we get to the negative part later. So here we need numbers whose sum will be 3 and the product is 2. That's simply 1 and 2. So when you add 1 and 2, you get 3. When you multiply 1 and 2, you get 2. So the final result would just be so if I substitute into the surd now, you have square root of 3 plus 2 root 2 equals root 1 x plus root y. So that's root 1 plus root 2. And root 1 is 1, root 2 is root 2. So the result then becomes square root of 3 plus 2 root 2, and that's equal to 1 plus root 2. Well, if you want to solve that, if you want to solve this simultaneous equation in a rigorous way, right? X plus y equals 3, xy equals 2. You can do that if you choose. So you have x plus y equals 3, and then you have xy equals 2. So call this equation 1 and call this equation 2, right? So, I mean, you can actually have, you can do any substitution you want to do. So you can say from equation 1, all right, y is equal to 3 minus x. Okay, y is equal to 3 minus x. So you can put y equals 3 minus x into equation 2. So in that case now, you have x, y. So y now is 3 minus x, and that is equal to 2. So you have 3x minus x squared equals 2, like that. So that means you have, if you transfer everything to the other side, you have x squared minus 3x plus 2 equals 0. So, of course, x squared minus 3x plus 2 equals 0, like that. So, and then you need two numbers, you multiply to get to, you add, you get minus 3. So that will simply be x squared minus x minus 2x, because minus x minus 2x is minus 3x plus 2 now equals 0. So you can factorize, you have x into x minus 1 minus 2 into x minus 1, like that equals 0. So you have x minus 1 into x minus 2 equals 0. So from that, x is equal to 1 or x is equal to 2. So we have got the two possible values of x like that. So you can then say from y, which is equal to 3 minus x. So you have you have for x equals 1, you have y equals 3 minus 1, which is 2. So you have 1, 2. X is 1, y is 2. Then for x equals 2, you have y equals 3 minus 2, which is 1. So here now you have x is 2, y is 1. So anyhow you have it, you have 2 and 1 as the values. So I think it's a waste. It might be a kind of waste of time. If you're in an exam situation, maybe you can do this to actually show the answers, right? But if you are doing like multi-choice and all that, just look for two numbers you add to get three, two, and with the same two numbers you multiply to get two, and that will usually be 1 and 2. So you just come back here and put it as root 1 plus root 2, which is, so whether you have 1 2 or 2 1, you end up getting 1 plus root 2. Either you take x to be 1 and y is 2, or you take y to be 1 and x is 2, you still end up getting the same thing. So but I mean, that's just to show that you can actually solve it of rigorously if you want. So general identity here is this. The key identity used is that the square root of the square of root x plus root y all squared is equal to x plus y plus 2 root xy. And then therefore expressions of the form square root of a plus 2 root b may sometimes be written as root x plus root y, where x plus y will be a and xy will be b. All right. And once you have that, you can look for two numbers that you multiply to get b, but you add to get a. So example one now, you want to simplify square root of 5 plus 2 root x. So we assume again that square root of 5 plus 2 root 6 is equal to, oh, we want to simplify square root of 5 plus 2 root 6 rather. So square root of 5 plus 2 root 6 is equal to root x plus root y. So when you, of course, the expansion, square both sides, you get 5 plus 2 root 6 equals x plus y plus 2 root xy. So that means x plus y is equal to 5 and xy, of course, 2 root xy is equal to 2 root 6. Divide both sides by 2, you get root xy equals root 6. Take square of both sides, you get xy equals 6. So you have two things now. X plus y is 5, xy is 6. So find numbers whose sum is 5 and their product is 6. Easily, that will be 2 and 3. So it means that square root of 5 plus 2 root 6 is the same thing as root 2 plus root 3. Well, I have this practice of checking to be sure if the answers, if they are basically the same. All right. So let's check to see. First one, this one, we have root 5 plus 2 root 6 equals root 2 plus root 3. So let's check. Root 5 square roots of 5 plus 2 square roots of 6. We have 3.146, blah, blah, blah. And we're told, we see that the answer is root 2 plus root 3. So we have square roots of 2, all right, plus square roots of 3. Exactly the same thing. So that means it's correct, right? So we go for example 2. Example 2 now, you have square root of 7 plus 4 root 3. So square root of 7 plus 4 root 3 is root x plus root y, square both sides, you get 7 plus 4 root 3. That is x plus y plus 2 root xy. And that means that x plus y is 7, the part without the radical, and 2 root xy is equal to 4 root 3. So x plus y is 7. So 2 root xy equals 4 root 3. Divide both sides by 2. So you have square root of xy equals uh, 2 root 3. So for the first time, we don't have the 2, there's still a 2 remaining here. So you have to pay attention to that because this 2 is not disappearing. So when you square both sides here, you're going to have square root of xy equals 2 root 3. So you square both sides, you get xy equals square of 4, I mean 2 squared times 3, that's 12. So you need two numbers which whose sum will give you 7 and the product will give you 12. That's easily 3 and 4, right? 3 plus 4 is 7. 3 times 4 is 12. So and it means you can write square root of 7 plus 4 root 3 as root 3 plus root 4. And root 4 is 2, right? So square root of 7 plus 4 root 3 is 2 plus root 3. So square root of 7 plus 4 root 3. 7 plus 4 root 3. Okay, we saw that to be 2 plus root 3, right? That's 2 plus root 3. 2 plus root 3. Exactly the same thing. So that works. Okay, so we go on to an example involving minus now. So example with a minus sign, you want to simplify square root of 5 minus 2 root 6. So here you have to assume that the square root of 5 minus 2 root 6 is the same thing as root x minus root y. Okay, so if you expand this now, you have x plus y. Root x minus root y would actually give us x minus 2 root xy plus y. So that means x plus y minus 2 root xy. So if you match the terms now, that means that x plus y will be 5, all right, and xy would be 6. So now you need two numbers satisfying this. Added together, you get 5. Multiplied, you get 6. That would be 3 and 2. So, of course, the bigger number should come first because, you can't get a negative number because you have a square root. So, I know if you solve this right, you're going to get a situation where x is 3 and y is 2. And you get another situation where x is 2 and y is 3. So, the x is 2 and y is 3 situation won't work, right? Because though it satisfies this, but it will not work for the surd, because you are going to be getting a negative value, which is not acceptable, right? So you have square root of 3 minus square root of 2. So we can check that. Square root of 5 minus 2 root 6. So square root of 5 minus 2 root 6. 2 root 6. And we are comparing that with root 3 minus root 2. So that's square root of 3 minus square root of 2. Square root of 2. Same thing. So that works. Okay, so quick recognition trick. For expressions of the form square root of a plus 2 root b, look for two numbers such that the sum of those two numbers will be a, whereas the product of the two numbers will be b, right? And then you can have you can express square root of a plus 2 root b as root x plus root y. So that takes us to the practice problem. So I'm going to take one from each. I think I'll take a negative one and a positive one. So let me take number 10, then I'll take number 10 and maybe number 15. So number 10 now, square root of 17 plus 8 root 3. Square root of 17 plus 8 root 3. Okay, so we want to simplify square root of 17 plus 8 root 3, right? So to simplify this, to simplify, square roots of 17 plus 8 root 3. So we can say uh, let square root of 17 plus 8 root 3 be the same as root x plus root y. So next, we square both sides. Square both sides. The reason why we are squaring both sides is to remove the square, to denest by removing the first square root. So it's more like you have a bag in a bag. So to get what is inside the inside bag, so you have to remove that bag from the first one, from the bigger one, right? So that's like removing the square root, and then you go ahead and try to sort whatever you have there. So now we want to square both sides. That means you have square root of 17 plus 8 root 3 all squared equals root x plus root y all squared. Okay, so square, we cancel square root here. So we have 17 plus 8 root 3 equals, when you expand this now, you get uh root x squared as x plus 2 root xy plus root y squared, that is y. Okay, so then you have 17 plus 8 root 3. So each part has a the radical part and the rational part. So 17 is the rational part here. And on the left right hand side, the rational part is x plus y. So x plus y plus 2 root x y. So the next thing we want to do is to compare terms, compare terms. So to compare terms now, first we have the rational part, which says that 17 is equal to x plus y. So we have that x plus y is equal to 17. So we have that. Then the irrational part, we have 8 root 3, okay, equals 8 root 3 equals 2 root xy, equals 2 root xy. So here we have to divide through by 2. Divide through by 2. So when you divide through by 2, you have 8 root 3 divided by 2 equals 2 root xy divided by 2. So 2 cancels 2. And then on this other side now, 2 here is 1, 2 here is 4. So you have 4 root 3 equals root xy. Okay, so we want to get rid of roots altogether, right? So we then square both sides to remove the roots. So square both sides. So when you square both sides, you have 4 root 3. Uh, you have 4 root 3 all squared equals root xy all squared. So that means you have 4 squared multiplied by 3, because that's root 4 squared, root 3 squared is 3, and that is equal to xy, because 2 cancels the roots. So now we have that xy is equal to, okay, let me keep going. 4 squared is 16. 16 times 3 is 48. So 48 is equal to xy. So now we have xy equals 48. So we have two expressions. So x plus y equals 17 and xy equals 48. We need two numbers added to give us 17, and multiplied, we get 48. Okay, so we're looking for factors of 48 that whose sum will be 17. So in that case, so we know 48, right? If you have 48, this one is not looking obvious to me. That's why I'm going this way now. So you have 48. So 2 in 48 is 24. 2 again, that's 12. 12 and 4 will not give us 17, right? So 2 again, we have 6, right? So what about 8 and 6? No. Then 2 again, that'll be 3. Okay, I think, oh, okay, that's still not working. So that's 16 times 3. Okay, now we have 3. Okay, so what can we do with this? Do we have two numbers multiplied that can give us 17? I hope I got the question right. So this is 17 plus root of 17 plus 8 root 3. That's question 10. Square root of 17 plus 8 root 3. I think that's fine. Okay, square root of 17 plus 8 root 3. It doesn't look like we have integers that meet this criteria. Um 48. 16 times 3 is 48, right? 16 plus 3 is not 17. So if that had been 19, it would have been fine. So what do we do? What can we do? This is 6 plus 3 is 18. 6 times 3. Okay, no. This is 16 times 3. Yeah. How about 8 times 6? 8 plus 6 is 14. So 14 would have worked too. So how about Uh, 12 and 4. Still not working. Okay. Okay. So I guess we have to solve. So so we have to solve like we did the other time. So solve equations. So we have so call this one and call this two. So I can, like I did before, I can just say y is equal to 17 minus x, from the first part. Then from the second one, which says xy equals 48. So we have x into 17 minus x equals 48, so that we have 17x minus x squared equals 48. So that will be 0 equals x squared minus 17x minus 48 plus 48. We still have the same problem because we can't, it's hard to actually get whole numbers that satisfy this. So we can do this: x squared minus 17x plus 48 equals 0. So we can use the formula method, right? We can use the formula method. We know x now will be um, minus b, that's minus minus 17, that's minus minus 17, plus or minus square root of minus 17 squared minus 4, minus 17 squared minus 4ac all over 2 times 1. So that means we have x to be square root, that'll be 17. So 17 plus or minus square root of 17 minus 17 squared is 289 plus 4 times 48. So 4 times 8 is 32. We have 3. 4 times 4 is 16. That's 192. That is subtraction, by the way. Yeah, subtraction. Yeah, all over 2. So we have x now to be 17 plus or minus, so 289 minus 192. Yeah, 48 times 2 is 96. Yeah, 192. So we subtract. This is 7. This is 9. So that's 97. This is serious. So we have 97. Okay. So this is plus or minus 97 divided by 2. So, well, in this case, we know that. Oh, sorry, this is root 97. Yeah, root 97. So in this case, we already know that the negative x won't work. So x equals 17 minus root 97. Root 97, okay, no problem. I think let's not be in a hurry. 17 minus 97 over 2, or x is 17 plus root 97 all over 2. Okay, and we have all that. So, and since you are dealing with surd, right, we don't want to go the decimal way. So these are the possible x's we can have. So we can then take it back here. So with this, I mean, we don't have the whole number that can do the job. So we now have to take this back. But since it is surd, it's better we just leave it here. So normally you have got the x's now. So you have to go back to 17 minus x. All right. So from y equals 17 minus x. Okay, we now have, so for each x now, you now have y equals 17 minus 17 minus root 97 all over 2. That's one answer. Or y equals 17 minus 17 plus 97 all over 2. I mean, that's looking not so friendly, but that's what we have. So, so if you're going to write this, we even have a more complicated problem than what we started with. But it's okay. I mean, I'll just go all the way and write it. But usually you won't have this situation. Okay. So then you can go back and say that. So, okay. So here we also have to be very careful. So here we have a smaller, bit confusing. 17 minus blah blah blah. Yeah, so just get your y, and at the end of the day, come back and have root 17 plus 8 root 3 equals root x minus root y plus root y, right? Root x plus root y, root x plus root y. Yeah. So you just fix them up. But now we have got more complicated situations than what we started with. So, but that's the way the question is. But it would have been a different story if this had been, say, if 17 had been like 19, or even if it was 14, because 19 is 16 times 3 is 48. 16 plus 3 is 19. Then it could have been good if it was 14 also, because 8 times 6 is 48, but 8 plus 6 is 14. So if you can try, instead of 17, you can try 19 and 14, you get perfect values. I trust. So but that's how that one is. So I go for question, something involving negative now. Let me take question 17. Root 13 minus 4 root 10. Root 13 minus 4 root 10. So root 13, roots, to simplify, root 13 minus 4 root 10. Okay, so what do we do? So we say let square root of root 13 minus 4 root 10 be equal to root x minus root y. So with that in place, we can square both sides like we did previously. So we have square root of 13 minus 4 root 10 all squared equals root x minus root y all squared. So we then have 13 minus 4 root 10 equals x minus 2 root xy when we expand that. So root x squared is x. 2 times root x root y, that's root xy, plus root y squared, that's y. So that means we have 13, the rational part, into the minus 4 root 10, the third part, equals x plus y, the rational part on the right hand side, minus 2 root xy, the irrational part. So we can then compare. So comparing, we have x plus y to be 13, and then we have x plus y to be 13. Call that equation 1. Or I mean, maybe we don't have to solve. Let's see. If you have the same situation like before, we have to solve. Then the other part, we have 2 root xy, 2 root xy. We have minus on both sides, so we don't have to worry about the negative. So 2 root xy equals 4 root 10. 4 root 10. So divide through by 2, we have root xy equals 2 root 10. And then square both sides. So you have xy equals 4 into 10. So when you square both sides, because that'll be that's like root xy squared equals 2 root 10 squared. So that'll be 2 squared times 10, like that. So so that's xy equals 40. So we need two numbers. We need x and y such that when we add, we get 13. When we multiply, we get 20. I think this 20 times 2 is, no, 20 times 2 doesn't give us that. 8 times 5, yeah, easily. So if the answer is there, you will easily know. So easily, all right, 8 times 5 gives 40, right? And 8 plus 5 gives 13. So we have to take x to be 8, and x is 8 and y is 5. In this particular order, because we have negative here. So this cannot be negative. So root x has to be bigger than root y, so that we don't have a negative answer. So now, when the answer is there, it will be obvious. So what do we do? So the original thing we started with is root 13 minus 4 root 10. Okay, root 13. So root 13 minus 4 root 10, which started as being root x minus root y, will have to be root 8 minus root 5. Okay, so root 8 now is root 4 times 2 minus root 5. So you don't forget to simplify. So square root of 2 is 2. Square root of 4 is 2. Then root 2 remains minus root 5. So we have that 13 minus 4 root 10 is simplified to be 2 root 2 minus 5. So we can confirm that from Desmos. root 13 minus 4 root 10, root 13 minus 4 root 10. Okay, root 13 minus 4 root 10. We have 0.5923, blah, blah, blah. And then the other one, we have 2 root 2 minus root 5. 2 root 2, 2 root 2 minus root 5. So exactly the same. So that's correct. So with that, we come to the end of this interesting video talking about nested sorts. So for the sake of what I discovered the other time, I want to change this question 19 to, so let this be 19 minus 8 root 3. So you can get, so 16 plus 3 is 48, but 16 times 3, I mean 16 times 3 is 48, and 16 plus 3 is 19. So you can easily get the result to that one. All right. So with this, I come to the end of this interesting video. Don't forget to try your hands on these practice problems. I've solved one of it. Then try your hands on this other, on the next 10 too, so that you can be sure you really get the gist. Let me know how helpful this is for you. Anyway, something like you'd like me to try out, feel very free to let me know. If you have subscribed to this channel already, I thank you very much for doing that. And if you haven't subscribed, question is, what are you waiting for? Go ahead, subscribe and hit the notification bell so you can always get alerted each time a new video is released. You can also become a member of the channel by clicking on join. That gives you special privileges like getting to see some videos first, or being the only one to see some videos because you're a member of the channel and you deserve that special privilege. You can also request for PDF copies of the notes I use in teaching. And of course, we can hang out to discuss whatever interests you on this channel. Ultimately, don't forget to comment, like, share, so that more people can have access to the great content I have going on here. So like, come your way again, keep doing maths right. Bye.